irresistible force such as you meets an old immovable object like me.
In pre-calculus, you will need to be able to take functions and add, subtract, multiply, and divide them in order to create a brand new function. This process is sometimes called combining functions. You've actually seen examples of this. For instance, your friend is buying a pair of jeans for $39.99. The jeans are on sale at 20% discount and the sales tax is 7%. So how much will your friend have to pay for the jeans? There's two functions involved in this problem, one involving discount and the other involving sales. Just for convenience, I'm going to use the following three functions to show you how to evaluate functions that result from the composition of functions. I'd also like you to try something now that may seem a little unusual. I'd like you to try this problem without any explanation. This says find the difference between these two functions. The function f, take away from it function g. So you just take function f and subtract function g. It's really just an algebra problem. I'd like you to pause the video now and try this. Come up with a guess. Come up with an answer. And I think you're going to be surprised. Because these two functions are both polynomials, solving this problem is really just about collecting like terms and then subtracting them. Just be careful of your negatives. So, collecting up my like terms, my answer is going to be negative x squared minus x plus 2. I'd like you to try this problem again with no explanation. Just try to add these two functions together. Pause the video now and see what you get. So this one's simpler than it seems. You take the f function and add the h function to it. Because one's a polynomial and the other's a square root, there's no like terms. The answer is simply x squared minus 6x plus 2 plus the square root of 3x plus 2. In this composition, you're asked to multiply two functions. Now, just remember to do the distribution, and you should be fine. Pause the video now, see what you come up with for an answer. I'm going to suggest you start off by writing what you've been asked to find. That is the product of these two functions. Then start drawing your arcs and make sure your distribution's right. So let's see, x squared multiplied to the second function, and then negative 6x multiplied to the second function, and then 2 multiplied to the second function. And I'm going to get a great big expression here. Once I distributed each term of the left polynomial to each term on the right, then I just have to combine my like terms. I like crossing them out just to keep track of them. And it looks like my final answer here is going to be 2x to the fourth minus 17x cubed plus 34x squared minus 10x. In this example, you're just asked to divide two functions, so I'm just going to write this one out quick for you because one's a square root and there's nothing you can do. But I'm going to ask you to pause and answer a question for me. The question is, does this new function have any undefined values? Pause the video for a moment, see if you can come up with an answer, and then start again when you're ready. Because the denominator now has a polynomial, there may be undefined values. What I need you to do is to set the denominator equal to 0 to start. Solve by factoring out the greatest common factor and find you have two solutions, x equals 0 and x equals 5 over 2. These are the undefined values. All right, now it's time to get to the main event. When you place one function inside another one, you're creating a composition of functions. For instance, if you have two functions, f of x and g of x, then the composition of f of g of x takes g and puts it in place of x in the formula for f of x. Let's look at an example. Remember what I said. You just place one function in place of the letter x in the other function. In this case, you're going to place the h function inside the f function. Pause the video now. Give it your best shot. So you start by substituting the entire h function for every x in the f function. A square and a square root cancel each other out. Simplify by combining like terms. And I'm going to be left with 3x plus 4 minus 6 times radical 3x plus 2. Let's try another. This is read as f of g of x. You simply put the g function in the f function. Pause the video now. Try for an answer. So this one isn't bad. It's a little tedious and you have to be careful. Take the g function and start by plugging it into f everywhere it says x. Multiply everything out first. Be careful how you distribute. Don't drop any terms. Good. Then combine like terms to get your final answer. Personally, I like to cross things off as I go so I don't drop anything. And there it is. How did you do? There's not a lot more to this. Try another one. Pause the video now, please. This time, place f into g where it says x. Now, the algebra can get really out of hand here quickly, so be careful. I'm squaring this polynomial, so I'm going to write it right out twice. Don't think of this as extra work. Think of this as insurance so you don't make a mistake. Now, when I multiply those two trinomials together, I'm going to get 9 terms. Then, at the end of that, minus 5x squared. Now, I got to multiply the 2 through my parentheses. Be careful. Just go slow. Then it's just a matter of taking care of my like terms. And this is one problem where crossing off my terms is very, very valuable. And so there you have it. 2x to the fourth minus 24x cubed plus 75x squared minus 18x minus 2. Not all of our answers are going to come out quite this big and complicated, so be patient. Okay, one more before we move on to something new. This time I'd like you to find h of f of x. That is, put the f function in for every occurrence of x in the h function. Pause the video now. Do your best. So substitute f for x in the h function. Distribute the 3 inside the root. And combine our like terms to get an answer of the square root of 3x squared minus 18x plus 8. Here's one I don't want you to get thrown by if you see it. What if we ask you for f of x? That is, put the f function into the f function. Pause the video now. So this time you're going to place f into itself everywhere it says x. When you multiply everything out, that is, take care of the square, distribute the two trinomials, 9 terms you have to keep track of, multiply through by the 6. Then I start combining like terms, and I'm going to end up with a final answer of, let's see, just take care of my 12. So I'm going to end up with a final answer of x to the 4th minus 12x cubed plus 34x squared plus 12x minus 6. Here's another one that's complicated looking, but it's too easy. I don't want you to mess this up. What if we asked you for the value of a composition of a function? So f of g of -1. Pause the video now. Do your best. So I could figure out the composition of these functions first, but I think there's an easier way. I mean, if I put g in for x in the f function, this is what I'll get. But what if I just pause for a minute and figure out what is g at -1? And I come out with an answer of 7. What if I take that and substitute it into the f function? And 49 minus 7 plus 2. So my answer turns out to be 9. If I'm asked to find the value of a specific point in a composition, here's one example on how I could do it. And now the saddest moment of all of any lesson, the end. This is our last problem. Would you find for me, please, g of h of 3? Pause the video now. So again, I could figure out the composition of these two functions and then put 3 into it, but I think what I'll do first is just figure out the value of the h function at 3, square root of 11, and then I'll take that and put it into the g function. So square and square root cancel, 2 times 22 minus 5 square roots of 11. And that's about it. You now know how to combine functions, to compose functions, and to evaluate the composition of functions at specific values. Thank you for your time and attention.
Sure as we live, something really got